Another series of phenomena spanning continents has been observed that when all data is considered seems inexplicable. However, we'll see hydroplate theory links these observations to the Genesis record of the flood. For centuries, unfossilized frozen mammoth and rhinoceros remains have been recovered from the tundra in northern Siberia, Alaska, and Canada. One such mammoth was recovered from Siberia's Beherovka River. The 50-year-old male was found in a freshly eroded bank 100 feet above the river in 1900. A year later, an expedition led by Dr. Otto F. Herz painstakingly excavated the frozen body and transported it to the Zoological Museum in St. Petersburg, Russia. Beherovka was upright, although his back was humped, and his hind legs were straight and rotated forward at the hips into an almost horizontal position. This strange, contorted position was further exaggerated by his raised and spread front legs, as if struggling to right himself. In the museum, Beherovka was reconstructed and displayed in the same body position as it was found. Several ribs, a shoulder blade, and the pelvis were broken. Amazingly, the long leg bone in its right foreleg was crushed into about a dozen pieces without noticeably damaging surrounding tissue. However, there had been considerable bleeding between the muscles and fatty connective tissues in this area. It is most likely that this leg was crushed after burial and not before. Here's why. First, it is doubtful that this severely damaged limb could have been used in the spread, struggling position it was found in, since the smashed bone would not have resisted contraction forces from the muscles, nor could it have supported any weight. Therefore, it seems the limb was fully functional and in use at the time of burial. Second, crushing of a mammoth leg bone without evidence of external tissue damage from a large impact while still showing bleeding in tissues near the crushed bone indicate rapid and deep burial soon after death. Falling into a deep, cold crevasse alone would only cause the bone to bend and snap in one place where it was the weakest. Think of pushing a wooden yardstick at the ends. It will bend and snap in one place. Beherovka's leg bone was crushed into a dozen or so pieces. This indicates the leg was encased and surrounding tissues were evenly compressed against and supported the bone so that it was not able to bend. Continued rapid burial from above vertically compressed the body and the surrounding layers as it was buried in. Since the bone, too, was being compressed but could not bend, crushing became the failure mechanism. The continued heavy burial above the mammoth's body must have happened during or soon after death for bleeding in local tissues to have occurred before they froze. Extremely good preservation indicates that the burial material must have been extremely cold as well. Other fossils were also buried around the site. Below his right forefoot was the end of a very hairy tail of a bovine animal, probably a bison. Also under the body were the right forefoot and left hindfoot of a reindeer. The whole landslide on the Beherovka's river was the richest imaginable storehouse of remains. In the surrounding loamy soil was an antelope skull and the perfectly preserved upper skull of a horse with fragments of muscular fiber still attached. Also tree trunks, tree fragments, and roots. This vegetation differed from the amazingly well-preserved plants in the mammoth's mouth and stomach. Many fossils are found in groups at high points in the land's topography. These are sometimes referred to as fossil graveyards. The fauna represented in these graveyards are diverse and sometimes they are prey and predator in close proximity. Being trapped in bogs are sometimes thought to explain the diversity, but bogs would be located at topographical low points. What would cause such diverse groups to gather in close proximity on hills? Raising water and/or sediments is most likely the explanation. The cause of Beherovka's death was determined to be suffocation because blood was found to be coagulated in its capillaries. Also, the male genitalia was found to be erect, which is a telltale sign of slow suffocation. Other mammoths recovered show similar signs of asphyxia and inhalation of dust and silts. Interestingly, the stomach contents were well preserved and showed little signs of breakdown by enzymes. This is unexpected. The mammoth's large thermal mass should have kept the stomach warm for a long time, even if Beherovka had died in the coldest Siberian winter storm. Since the body was rapidly buried, this is even more perplexing since burial should have protected from exposure to the cold. The plants found in the stomach and mouth were so well preserved that each species of fauna could easily be identified. It is almost as if the body was buried in something colder than dry ice. Some of the plants found were not native to Siberia today. The extreme preservation also told examiners when the plants were eaten. Inexplicably, this pointed to a late summer death when temperatures would have been warm. Every time a frozen mammoth's time of death can be determined, the estimates are of a late summer to early fall time frame. This is surprising if each death were random and speaks to the possibility that a large-scale event killed and preserved these bodies. A warm weather death flies in the face of traditional theories attempting to explain the preservation of frozen mammoths. What's more is that the recovery team reported the meat was not putrid or rotten, but fresh enough that their sled dogs ate some of it and did not get sick. Close examination of Beherovka's soft tissues showed the cell walls had not burst, as they would have at normal freezing temperature rates. For this to happen, the cell needs to freeze rapidly before breakdown produces water within the membrane, otherwise the water's expansion upon freezing tears the cell wall open. For this to happen, frozen food experts point out that a live animal of this size would have to be exposed to extreme cold of less than negative 150 degrees Fahrenheit in a blast freezer. The preserved stomach contents deep inside the warm carcass indicate external temperatures must have been below negative 175 degrees Fahrenheit. The puzzle of replicating the observations are almost unbelievable. Remember, the crushed leg bone indicated rapid burial soon after death, which normally would have insulated the still warm body. So Beherovka had to be buried in contact with at least some fill material that was at least 65 degrees colder than dry ice. But how could temperatures have dropped so rapidly during the summer? And even if we can imagine a freak cold snap, this does not explain what must have been sustained cold that could have kept the body from rotting all this time. Before tackling this challenging scenario, let's first cover some more info on just what type of environment the woolly mammoth appears to have lived in. Because they have long hair and are found in what is now the Arctic Circle, it is automatically assumed mammoths are Arctic animals. But the easiest and most accurate way to determine an extinct animal's or plant's environment is to identify familiar animals and plants buried nearby. For the mammoth, this includes rhinoceros, tigers, horses, antelope, bison, and temperate species of grasses. All live in warm climates. Some burrowing animals are found too, such as voles, which would not burrow into rock-hard permafrost. Even larvae of warble flies have been found in frozen mammoths' intestine, larvae identical to those found in tropical elephants today. No one argues that these smaller animals and plants buried near the mammoths were specially adapted to the Arctic, so why do so for mammoths? Most assume mammoths are adapted to the cold. However, studies of recovered DNA fragments show mammoths to be closely related to the Indian elephant. Many mammoths are found with heavy layers of fat, assumed to be for insulation. However, fat only comes from caloric intake. Fat is an indication of ample food supply that the Arctic does not provide. Arctic herbivores today have little fat. Another popular myth is that mammoths have woolly insulation. Actually, mammoth wool is just hair. Unlike actual wool, mammoth hairs have no overlapping scales to trap air. Besides, sheep have wool but do not live in the Arctic. And mammoth hair is not even insulating like fur. Mammoth skin has no erectile muscles or oil glands to produce the insulating properties found in fur. Some say the large tusks were used to move snow and ice to get to food. This is ridiculous. Some mammoths seem better fed than their modern cousins who are surrounded by food that they don't have to work for to expose. How could a mammoth work all day clearing snow in the cold just to eat and be fatter than a tropical elephant? Carrying heavy tusks around means more work, which requires more calories, and they'd have a lot of work to do just to stay healthy. Grown elephants average 300 pounds of food and 30 to 60 gallons of water per day, and they spend most of their waking hours eating it. Imagine shoveling snow all day with the equivalent of 2 sticks in the Arctic temperatures, eating frozen or nearly frozen food. I'd think I'd be exhausted, cold, and hungry. Considering this, the evidence clearly points to mammoths being temperate creatures living amongst other temperate fauna in a food-rich environment. The perceived cold weather adaptations are purely imagination. There are other evidences that the environment buried under the tundra experienced a rapid freeze. Second-hand reports describe the apparent near-instant freezing of a flowing river found buried in the frozen ground, with fish frozen in place. Rivers do not freeze instantly. Rather, they freeze from the top down. The ice insulates the remaining flowing water below and prevents complete freezing. A second report is even more surprising. 50 oxen were found trapped in a remote frozen river. They were found as if attempting to cross when the river instantly froze them in place. How could a river freeze so fast that a large, powerful animal could not exit in time? Other findings in the Arctic indicate rapid freezing of a once lush, temperate region. Barren Axel Heiberg Island and Ellesmere Islands are found to have once supported temperate animals and vegetation, which are now buried under the tundra. Note that some animals recovered are burrowing animals that could not dig into rock-hard permafrost. Others are cold-blooded. Large trees were also found. In fact, vast frozen, non-fossilized forests that once thrived in the now barren Arctic Circle continue to surface as summer runoff erodes and releases the timber from the frozen muck. Driftwood of large, non-native trees released from the seafloor still washes up on the shores of remote islands north of Siberia. Northward flowing rivers erode the muck below and see driftwood collect along their banks as it is carried out to sea. Because there are almost no trees growing now in these latitudes, natives use the driftwood as a source of fuel and building material. Oil drilling in northern Alaska commonly penetrates what is described as a flattened, unfossilized forest under hundreds of feet of frozen muck. There is a glaring problem with this. The frozen trees are not native to the Arctic. These tree species only grow in comparable forests thousands of miles further south. We might imagine a global climate being warmer in the past and that this would explain this thriving forest. But the problem is more than just the cold temperatures. These trees need a certain amount of sunlight just to live. These latitudes do not provide sunlight for these trees to ever grow, even if temperatures were right. There is a reason these trees show such barren landscapes. Trees do not do well here. The Antarctic also reveals similar evidence that the climate was what's warmer on it. Large deposits of coal and oil indicate large forests. Dinosaur fossils also indicate a warmer climate. Remember, these indications of rapid and permanent freezing of temperate to tropical flora and fauna are spread over 2 continents, and the type of flora recovered could never grow at the extreme latitudes they are now located. So simple climate change cannot completely account for what we observe. Therefore, any theory must explain how these plants grew and how they received the solar energy they require to grow as they did. Only hydroplate theory will fully explain what happened. We will now unwrap hydroplate theory's explanation of events by answering these questions that any theory must address. How did it get so cold so fast during late summer? If the poles were warm, what happened? How did plants get sunlight? How did it stay cold? The answer to the first question is cold hail. Extremely cold hail. During the early stages of the flood, as the fountains of the deep burst and shot water high above the atmosphere, some of the water, laden with sediments, soon froze as it radiated heat into supercold space. Above the atmosphere, temperatures are well below negative 150 degrees Fahrenheit, especially on the night side of Earth. These frozen droplets were supercooled well below normal freezing and were transformed into muddy hail which fell back down, blanketing vast areas in thick blankets of extremely cold hail. These warm climates were quickly transformed in hours. The dense sediments trapped in the hail caused it to sink to the bottom of any bodies of water. The heat from even flowing rivers was quickly absorbed by the supercold hail, and some rivers froze from the bottom up, trapping fish and even crossing herds whose feet were quickly frozen in place. Having originated from the supercritical water far below the surface, the water in the hail contained not only dissolved sediments and minerals, but also dissolved gases like carbon dioxide. Low points in topography soon became suffocating death traps for any air-breathing animals. Larger animals were able to move further through the freezing hail and toward safety of high ground before being overcome by either low oxygen levels in the air or exposure to the unrelenting cold of the hail. The hail's close contact with the bodies conducted heat extremely fast, freezing and encasing tissue soon after death. As the flood continued, muddy waters deposited more heavy sediments on top of the frozen layers, which compressed the bodies. So cold hail can explain the extreme cold. But what about the next summer and the years to follow? How did these remains stay frozen when the region appears to have been a warm, temperate to tropical zone? What about the last 3 questions? Hydroplate theory offers one simple answer for all three questions: the big roll. Earth spins around its axis, and we assume the continents have always spun in the same direction. However, as we've discussed, there is a problem with explaining how temperate plants and animals could survive, much less even thrive, at high latitudes relative to the sun's rays. Could Earth's surface have shifted? If so, how? Was the formerly temperate region originally further south and much closer to Earth's equator? If so, there should be other large-scale evidences of this alleged roll pattern that should line up with this idea. And as we'll soon discover, these evidences most certainly exist and line up as expected. Remember, according to hydroplate theory, before the flood, the mass on Earth's surface was somewhat evenly distributed. However, after the separation of the hydroplates followed by the compression event and the melting of the inner Earth, the Earth's surface mass became unevenly distributed. Newly created mountain chains from the compression event and contraction of the mantle set the freely spinning Earth temporarily out of equilibrium. The Himalayan mountains and the high Tibetan plateau became the highest, most concentrated area of mass on the Earth's surface. For any spinning object, each point of mass is acted upon by centrifugal force. If the mass of all points on the object's surface are even, then there is equilibrium and the surface spins stably relative to the spin axis. However, if you were to arrange mass unevenly on the surface, the area of concentration with the increased centrifugal force will drive that area toward the equator of the spinning object. Notice that even though the spinning object rolls relative to the equator, the object's axis of spin does not roll or tilt significantly at all. Since the Earth is spinning in frictionless space, this seemingly impossible scenario played out quite readily as the laws of angular momentum naturally pursued a new state of equilibrium after the compression event. Notice that depending upon where the mass concentration is located affects what parts of the surface rolled the furthest. Areas directly in line with the extra mass see the greatest roll from the equator, while areas adjacent see little movement at all. 2 points of the equator see no roll movement whatsoever. Pre-flood mammoths lived in a temperate to tropical region near the equator. The concentrated mass of the newly formed Himalayas caused them to drive toward the equator as Earth spun. As this happened, the entire Earth rolled, which caused some temperate and even tropical regions to end up permanently frozen as they were rolled to higher latitudes. Of course, other newly formed mountains also formed around the Earth, so the Himalayas were eventually counterbalanced by these other masses. This is why the Himalayas did not roll all the way to the equator. Many animals froze in supercold hail remained preserved as their new Arctic latitudes soon became permafrost. These animals seem to be out of place because they are out of place. This explains why so many animals recovered from the permafrost today are well preserved in spite of many evidences that they died in a temperate zone in late summer, and therefore should have experienced advanced decay. Some corroborating evidence suggests this roll happened quite rapidly, once the mass imbalance from the newly formed mountains occurred. Many see Oregon's Steens Mountain lava flows as more evidence of imagined magnetic reversals, which we've already shown to be a severe misinterpretation of the data. However, in light of the rolling surface scenario, a much different picture unfolds in the rocks on Steens Mountain. It is a case of relative motion. Obviously, the lava records movement as magnetic crystals are seen progressively oriented at steeper and steeper angles as it cooled. But what was moving, the magnetic field or the mountain? Rather than the magnetic field flipping and moving via unknown processes, we see that actually it was the pool of cooling lava which was moving rapidly through Earth's magnetic field, which continued to flow along Earth's stable spin axis. Since the lava was carried along on Earth's surface as it rolled, its magnetic components froze at different angles, recording the movements of the roll, which achieved rates of up to 6 degrees per day. There is yet more evidence of this roll and its approximate magnitude. Just south of the massive Himalayas, a peculiar 3,100-mile formation termed a progressive seamount runs almost straight and almost parallel to the 90th meridian. For this reason, it is called the 90 East Ridge. There is nothing else like it in the world. Plate tectonic theorists assume hotspots from the mantle have somehow produced this, but there is much debate over how this actually happens. In addition, plumes do not address why the ridge is so straight, nor why it aligns almost parallel with the Earth's axis of spin, nor why it is located directly south of the Himalayas. Of course, by now you should remember that since magma is compressible, plumes from Earth's outer core could never rise anyway. Hydroplate theory's concept of the big roll offers a simple explanation for the ridge. Because of Earth's spin, the Earth is not exactly spherical. Centrifugal forces cause the equator to bulge. Of course, the equatorial bulge existed before the flood and before Earth rolled. Assume the blue line represents the pre-flood equator. Assume you tied a red cord tightly around the Earth at the inclined angle shown just below the base of where the Himalayas would have eventually formed. Because of the equatorial bulge, the distance around the equator is greater than the distance covered by the red cord. Now, if Earth suddenly rolled about this spin axis so that the red cord was now spinning at the new equator, the centrifugal forces from the inclined bulge would begin to act to reshape the surface of Earth to form a new bulge that realigned with the new equator. This would put tremendous tension on the red cord, causing it to snap. Of course, this did not happen all at once, but in a series of lesser movements over a period of time as the imbalances from the Himalayas were equalized by other newly formed chains and as the bulge moved. Let's now align our view with the area south of the Himalayas as they rolled toward the equator. As the spinning Earth progressively rolled because of the Himalayas' mass, material just above the bulge was stretched as the bulge realigned with the new equator. At a weak point far south of the Himalayas, the surface material fractured and ripped open, allowing newly melted shallow magma to expand and rise up to fill the rip. Every time the Himalayas progressed south, the already weakened material at the crack ripped a little further. Because the rip was always the first point of the greatest stress concentration, it was naturally the easiest place for the next rip to form and relieve tension. For this reason, there was not a corresponding rip in the opposite side of Earth, where the bulge was also reshaping the surface as it rolled. Just as we'd only expect the red cord to break in only one place, so too the Earth's crust ripped only at one location. So it continued to propagate northward as Earth rolled. This explains why the 90 East Ridge's formation is so straight and why it runs almost parallel to the 90th meridian just south of the most massive point on Earth's crust. The length of the rip that formed the 90 East Ridge tells us approximately how far the Earth rolled, which works out to be about 40 degrees of roll angle. If we trace a line from the ridge through the Himalayas and continue straight through to the North Pole, as shown at this angle, and then use the same distance d that we just measured to trace from today's North Pole back down the traced line, we get a close approximation for the location of the pre-flood North Pole where Central Asia is right now. Now let's take a second look at the seemingly strange findings of out-of-place flora and fauna in today's Arctic and see if hydroplate theory's explanations match observation. The pre-flood Arctic Circle that would see little sunlight would be inside the white dashed line. Notice Steen's Mountain would be almost right on the pre-flood equator, almost opposite of the Himalayas, so naturally saw a good deal of surface roll as was recorded in the cooling layers, which were a product of the compression event and were still cooling as they rolled through the magnetic field. The pre-flood equivalent of the Tropic of Cancer would run along this green line. Now notice the proximity of the Axel Heiberg and Ellesmere Islands to this pre-flood tropical zone, remembering tropical plants and animals were found there. Also notice that the location of the heavy frozen forest under Prudhoe Bay and the North Siberian driftwood, all previously out-of-place findings, now readily align with their expected pre-flood latitudes. Of course, the mammoths lived in a temperate to tropical habitat, as so many evidences indicate. The antipode of the pre-flood North Pole was the pre-flood South Pole, which was located off the coast of where South America now rests. Of course, Antarctica's dinosaur fossils, coal, and oil deposits indicate a temperate climate as well, which as you can see lines up with expected pre-flood latitudes. Notice the location of Mesopotamia and Mount Ararat, the region where Noah landed and, assuming the ark didn't drift more than a few thousand miles, where he probably was living before the flood. They likely experienced little latitude change during the roll event because they were adjacent to the Himalayas, so even Noah's initial position on the pre-flood globe was optimal for limiting the extent of climatic change that he would experience. Again, we see that hydroplate theory's few assumptions combined with insightful, well-grounded scientific scenarios do a good job of explaining much evidence that is confusing and seemingly contradictory. To continue with the hydroplate theory overview, please click the following link to the next segment.